Unintended consequences of the DART spacecraft hitting an asteroid. The debris may end up on Mars. As it turns out, the hailed DART mission as a success may have unintended consequences. In September 2022, a probe sent from Earth hit the asteroid Dimorphos. This intentional collision was intended to change the object's trajectory. The test was successful. However, recent observations suggest that dozens of boulders ejected by the asteroid impact may fall on Mars in the future. On September 27, at 1:14 a.m. Polish time, telescopes around the world focused on the Dimorphos asteroid to record a historic test of our ability to defend the Earth against a potentially planet-threatening asteroid. It was the first experiment conducted by humanity that aimed to change the trajectory of an object in space. The DART, Double Asteroid Redirection Test, probe hit the asteroid Dimorphos. A small body only 160 meters in diameter. Dimorphos is a moon of a larger 780-meter diameter rock called Didymos. None of these asteroids threatened Earth, but they were considered an ideal target for testing the possibility of changing the trajectory of a space object. This was the first successful test of planetary defense in which an asteroid's orbit was modified by impacting a spacecraft. The refrigerator-sized DART probe, weighing less than 600 kilograms, hit an asteroid the size of the Great Pyramid of Giza at a speed of 22,500 kilometers per hour. Before impact, Dimorphos took 11 hours and 55 minutes to orbit Didymos. Analysis of data collected by ground-based and space-based telescopes showed that the DART spacecraft changed Dimorphos' orbit by 32 minutes, shortening it to 11 hours and 23 minutes. In recent observations of the Didymos-Dimorphos system using the Hubble Space Telescope, scientists identified 37 boulders ranging from 4 to 7 meters in size that were ejected from the system during the collision with the DART spacecraft. Marco Fenucci from the European Space Agency and co-author of the new study, traced the trajectory of these boulders and conducted simulations that predicted their location at 20,000 years into the future. By estimating the dynamics and motion of rocks thrown out during the collision, it turned out that they may hit Mars in the future, as researchers point out in their analyses, the results of which were published in the arXiv preprint database. These 37 large boulders escaped the gravity of the Didymos-Dimorphos pair and are now following a different path than the dust and rock tail stretching for over 10,000 years. Kilometer, which was created as a result of the impact. Distant forecasts. There are, of course, many uncertainties associated with making such long-term forecasts. However, Fenucci and his team found that in most scenarios, the identified boulders would cross Mars orbit in about 6,000 years. Numerical simulations show that all these boulders will cross Mars orbit many times over the next 20,000 years, the team wrote in the publication. Fortunately, none of the identified boulders is on a collision course with Earth. However, there are many factors that can change the path of these boulders. For example, Sunlight can cause the release of gases in the rocks and change their trajectory. If one of the rocks hit the planet, it could create a crater about 200 to 300 meters wide. Whether space rocks hit the surface of the red planet will depend on their composition. The study's authors say that if their structure is unstable, they will likely explode or burn up in the thin Martian atmosphere. But if they are solid enough, they will leave an impact crater behind. Intriguing correlation between earthquakes and cosmic rays. There is a clear statistical relationship between global seismic activity and changes in the intensity of cosmic radiation recorded at the Earth's surface, inform representatives of the Institute of Nuclear Physics of the Polish Academy of Sciences. This could potentially help predict earthquakes, but the correlation still needs to be explained. Strong earthquakes usually result in many human casualties and huge material losses. The scale of the tragedy could be significantly reduced if we had the ability to predict the time and place of the disaster. As part of the CREDO project, initiated in 2016 by IFJ Pan and Krakow, an attempt was made to verify the previously known hypothesis that it is possible to predict earthquakes by observing changes in cosmic radiation. Analyzers have shown that there is indeed a statistical relationship between both phenomena, but it shows features that no one expected, informed representatives of IFJ Pan. At first glance, the idea of a connection between earthquakes and cosmic radiation, in its original form reaching us mainly from the Sun and from the depths of the universe, may seem strange. However, its physical basis is fully rational, emphasizes Dr. Hab, quoted in the release. Pyotr Hamola, IFJ Pan and Astro CNTCAMK Pan. CREDO coordinator and first author of the article describing the discovery published in the scientific journal, Journal of Atmospheric and Solar Terrestrial Physics. The main idea here is the observation that eddy currents flow in the liquid core of our planet, responsible for generating the Earth's magnetic field. This field deflects the paths of charged particles of primary cosmic radiation. Therefore, if large earthquakes were associated with disturbances in the flow of matter driving the Earth's dynamo, these disturbances would change the magnetic field, which in turn would influence the paths of primary cosmic radiation particles in a manner dependent on the dynamics of disturbances in the interior of our planet. As a result, ground-based detectors should notice some changes in the numbers of secondary cosmic ray particles recorded. Physicists from CREDO, as IFJ Pan informs, analyzed data on the intensity of cosmic rays from 2 stations of the Neutron Monitor database project, collected in the last half a century, and the Pierre Auger Observatory, collected since 2005. The choice of observatories was determined by the fact that they are located on both sides of the equator and use different detection techniques. The analyzers took into account changes in solar activity, described in the database maintained by the Solar Influences Data Analysis Center. Key information about Earth's seismic activity came from the American-US program Geological Survey. The analyzers were carried out using several statistical techniques. In each case, for the period under study, there was a clear correlation between changes in the intensity of secondary cosmic rays and the total magnitude of all earthquakes with magnitudes 4 or higher. Importantly, this correlation only becomes visible when the cosmic ray data is moved 15 days ahead of the seismic data. This is good news because it suggests the possibility of detecting upcoming earthquakes well in advance. Unfortunately, the analyzers conducted do not indicate whether it will be possible to indicate the place where the cataclysm occurred. Correlations between changes in cosmic radiation intensity and earthquakes are not visible in analyzers related to specific locations. They only appear when seismic activity is taken into account on a global scale. This fact may mean that changes in the intensity of cosmic radiation reflect a phenomenon that our planet is subject to as a whole. In the world of science, it is assumed that a discovery can be considered when the level of statistical confidence in the data confirming it reaches 5 sigma, i.e. standard deviations. We got more than 6 sigma for the observed correlation, which means there is a less than 1 in a billion chance that the correlation is a coincidence. We therefore have very good statistical grounds for claiming that we have discovered a truly existing phenomenon. The only question is whether it is really what we expected, Dr. Hamola wonders. It turns out that the global nature of the observed phenomenon and the 15-day advance of seismic activity, visible in cosmic radiation, are not the only intriguing puzzles related to the discovery. A big surprise is the large-scale cyclicality of correlations, a phenomenon that no one expected. The analyzers show that the maximum correlation occurs every 10 to 11 years, i.e., in a cycle similar to the solar activity cycle. However, it does not coincide with the maximum activity of our star. Moreover, both cosmic ray and seismic data share other common periodicities of unknown nature. An example may be periodic changes in seismic activity and the intensity of secondary cosmic radiation in the cycle corresponding to the Earth's sidereal day, equal to 24 hours minus approximately 236 seconds. Could the cosmic seismic correlations be caused by some factor reaching us from outside the solar system, capable of simultaneously causing radiative and seismic effects? But what conventional physical phenomenon could even qualitatively explain the apparent correlations? The lack of classical explanations for the observed cyclicities provokes consideration of the possible role of other, less conventional phenomena. One of them could be the Earth passing through a dark matter stream modulated by the Sun and other massive bodies in our planetary system. The Earth with its sensitive magnetic field is an extremely sensitive particle detector, many times larger than detectors built by humans. Therefore, it should be possible that it may react to phenomena invisible to previously used measuring devices, regardless of the source of the observed cyclicities. At this stage of research, the most important thing is that we have demonstrated a connection between cosmic rays recorded at the surface of our planet and its seismicity, and if we can be sure of something, it is that our observation indicates completely new, exciting research possibilities, sums up Dr. Hamola. The International CREDO, Cosmic Ray Extremely Distributed Observatory project is a virtual cosmic ray observatory open to everyone, collecting and processing data coming not only from sophisticated scientific detectors, but also recorded using a large number of smaller detectors. The leading ones being CMOS matrices in smartphones, to transform your smartphone into a cosmic radiation detector. Just install the free CREDO detector application. The program is available free of charge. For Android smartphones, you can download it from the official Google Play Store or IFJ Pan account. More on this topic in the text. The main tasks of CREDO: it is necessary to monitor global changes in the flow of secondary cosmic radiation reaching the surface of our planet. This radiation is produced most intensely in the Earth's stratosphere within the so-called Regana-Pfalzer maximum, where particles of primary cosmic radiation collide with gas molecules of our atmosphere and initiate cascades of secondary particles. Synthetic human embryos were created in the laboratory. Scientists have managed to create human embryos from stem cells, without the need to use eggs or sperm. By developing these synthetic structures, further research into various genetic disorders and diseases will be possible. However, questions arise regarding legal and ethical issues. Synthetic embryo models provide insight into the early stages of human development. For example, they do not yet contain the beginnings of a brain or a heart, but they do have cells necessary for the formation of the placenta and yolk sac, as well as the embryo itself. These structures were grown as the equivalent of a 14-day-old embryo in the mother's womb. It is unclear whether they could mature further. The findings have not yet been published in a peer-reviewed article. Professor Magdalena Zernicka-Gertz, a developmental biologist from the University of Cambridge and Caltech, announced the research at the annual meeting of the International Society for Stem Cell Research in Boston. Scientists say they do not want to grow children in the laboratory. They hope that synthetic models will help them better understand early human development. This type of research may lead to the development of new therapies for genetic, pregnancy and developmental disorders. Our research is not aimed at creating life, but at saving it, admitted Zernicka-Gertz. U.S. law allows human embryos to be grown in a laboratory for a maximum of 14 days. After this time, Research into the development is difficult and scientists must rely on pregnancy scans. Experts in the field of stem cell research emphasize the importance of the discovery for better understanding embryonic development. The ability to recreate the early stages of human development using stem cells is an extraordinary breakthrough in cellular and reproductive technologies, says Dr. Rodrigo Suarez from the University of Queensland. The potential benefits are enormous and will allow us to better understand how early tissues self-organize at stages that we have not been able to study so far, adds the scientist. Details of the research led by u9GIQ are not known because they have not been published yet. However, their author admitted that the embryo structures were created from embryonic stem cells in the laboratory. Stem cells can be programmed to develop into any other cells. Here, stem cells have been coaxed into becoming the cells that will eventually form the yolk sac, the placenta, and ultimately become the embryo itself. The embryos created in this way resemble embryos at the earliest stages of human development. We have learned to create models resembling a human embryo by reprogramming embryonic stem cells, u9GIQ said in Boston. u9GIQ's team has previously developed synthetic embryos of monkeys and mice. More on this topic in the text. Synthetic mouse embryos with a beating heart and a brain embryo grown in the laboratory. However, crossing the scientific milestone and creating human embryos presents a number of ethical and legal hurdles. One of the basic questions is, how similar are these structures to natural embryos? If these models are very similar to normal embryos, then in some sense they should be treated the same. However, this is not currently the case in the legislation. People are worried about this, explains Professor Robin Lovell-Badge of the Francis Crick Institute. It is not yet clear how these synthetic embryos might develop or be used in research. If lawmakers determine that they are not equivalent to human embryos, they could potentially be useful in research currently considered too risky, said Dr. Evie Kendall of Swinburne University of Technology. Previous animal research is inconclusive as to whether synthetic embryos can develop into viable fetuses. In the case of monkeys, the embryos did not develop at all, while in the case of mice, the embryos developed enough to develop beating hearts and brains. Most experts agree that there is an urgent need for regulators around the world to start adapting to the pace of new discoveries. A clear definition of synthetic embryos is needed and exactly how they can be used. OmniVision, the smallest camera in the world. It is the size of a grain of sand. Engineers from OmniVision have developed a photosensitive matrix the size of a grain of sand. The tiny device is just over 0.5 millimeter and will be used in medical imaging. The OmniVision OV6948 matrix has dimensions of 0.575 by 0.575 by 0.232 mm and generates a color image with a resolution of 40,000 pixels, 0.04 megapixels. together with the housing containing the photographic module and a lens with a 120-degree viewing angle. The equipment has dimensions of 0.65 by 0.65 by 1.158 mm. The resolution may seem low, but for medical and diagnostic applications it should be sufficient. The OVM6948 camera is designed to be used inside the human body, giving doctors the ability to non-invasively assess the condition of internal organs. This equipment will allow the construction of miniature probes, specular and endoscopes with a diameter not exceeding 1 mm, which will significantly increase the comfort of patients during the examination. Thanks to such miniaturization, it will be possible to take photos in even the smallest blood vessels. The camera can be used in neurology, laryngology, cardiology, urology and gynecology. Produced by the Californian company OmniVision Technologies Inc., the camera records photos at 30 frames per second. It gives a depth of field ranging from 3 mm to 30 mm. The camera has low power consumption, which means less heat is generated. This, in turn, will allow the treatment to last longer. Equipment initially developed for medical endoscopes and small outer diameter catheters, however, has a much wider range of applications. Apart from medical purposes, it will certainly be used in various industries and forensics. Spies and detectives should also be happy. The developed device is not a prototype, but a finished product. Its authors admit that it will have a significant impact on medical imaging. The new matrix entered the Guinness World Records list for the smallest image sensor commercially available.